In our fourth episode of the Rated XDR series, we'll look at XDR by acquisition with Palo Alto Networks. I'm Randy Watkins, and this is Son of a Breach. Quickly building on the success of their next-generation firewall business, Palo Alto Networks has been a disruptor in cybersecurity. Now a leader across multiple competencies, including network security, cloud security, and security operations, the ability to acquire and integrate new technology allows them to quickly compete in new verticals. Joining me today from one of their more recent acquisitions, Expanse, to talk about Palo Alto Networks' strategy around XDR is the former CEO of Expanse and current SVP of Products for Cortex, Tim Junio. Tim, thanks for joining us today.
Thank you so much for having me.
Now, before we get started, let's do a quick run through of your career from Intel analyst to CEO and now SVP of Products for Cortex.
So I started my career at CIA when I was 20 as an intern before I could legally consume alcohol. I was working in the part of the organization that does cyber operations and analysis. And that converted into a full-time staff position. So I went to work there after I graduated from college. And then I decided to go to graduate school, went and did a PhD at UPenn. During that time, I did consulting work at DARPA, including in building cyber operational capabilities for the military. And I did a postdoctoral fellowship at Stanford, which brought me out to California. So after I made my way out to Silicon Valley, was connected with some other graduate students who had been working at DARPA as well as consultants. And we started the company to effectively continue that prototyping work. And so a little different from a typical startup story, we didn't set out with a particular product we wanted to build and then, get VC funding to build, the first version. Instead, we started the company thinking we had good ideas about where to go from at the time we called it big data, which I guess nobody says anymore, but large scale, data computation projects and cyber operational capabilities. And so we wanted to be able to continue to prototype, but have control over our future in terms of what happened with those prototypes. And so having our own company was kind of necessary to be able to decide, are we going to try and commercialize or, what path do we want to take with things that we build? So the foundational technology for Expanse was first seeded by DARPA. It was one of those prototypes that we worked on. And when we saw a viable path to commercialization with what we now call attack surface management technology, we decided to double down on that. And it was at that point in the company's history, we raised VC money and became more of a traditional startup where we went out, started getting corporate customers and selling a software product.
That's awesome. So from a kind of an advanced development background, looking at problems that the government was solving that really wasn't available to the private industry yet, and then bringing that technology out to kind of address the same attacks that the government was hoping to stave off by developing it in DARPA and in-house anyways.
Yes. So going back to 2013, 2014, around when we were first thinking about what is the core technology for Cortex Expanse today, we observed that the internet was kind of a mess. As soon as you started looking at large scale for exploitable systems, back then we found a huge number. Today there's still a large number, but not as large a number. So back then the premise for defenders was kind of like, the network is so big, you're going to try and do penetration testing and always be looking for weak links, et cetera. But the idea that you can, in an automated fashion, find exposures as soon as they come up, like within minutes, was not a reality that defenders were prepared for. And it took over, it's been now 8 years. Over the course of the last 8 years, we have seen major internet events that have borne out that thesis that you can actually automate looking for exploitable systems and that attackers would start to do so. So when we see new exploits published, like earlier this year with Microsoft Exchange servers as an example, we see attackers starting to look for vulnerable systems extremely quickly. And so that is now just part and parcel of how you have to operate a large enterprise network.
Looking at the Expanse acquisition, for those who don't know, attack surface management or attack surface protection, whatever they're coining it now. It's really taking an attacker's eye view of the organization. So what do they see from the internet? What applications are exploitable? What systems are available? And in today's age of instantaneous misconfigurations, having something continuously monitoring that and alerting to a potentially just innocent misconfiguration can really save quite a bit of breach. So it was pretty obvious why Palo Alto went after that data, right? It is kind of a bane in security that you don't really know what you're protecting against. You don't really know what it looks like. So it made sense why Palo went after Expanse. Palo Alto has also acquired Cyvera, Light Cybersecurity, Demisto, Redlock, countless others. There's been a ton of acquisitions, and they've gotten better over the years at folding in those acquisitions. Can you shine some light, having come from that side of the table, on what that integration process is and how it's kind of evolved as Palo Alto has moved into more of a DevSecOps model with continuous release cycles?
So as soon as we came into the company, actually even before the acquisition closed, after we had signed the letter of intent, we were already talking about how Expanse would be a part of the broader Cortex platform. And so Cortex, for those of you who don't know, is the part of Palo Alto Networks that we view as kind of the data hub for security data. So doing the artificial intelligence, machine learning type research for the company across many different data sets. And Expanse is part of that bigger story. But even before the deal closed, we were talking about where Expanse could plug in. And the first most obvious is where Palo Alto Networks next-gen firewalls are not running are potentially vulnerable parts of customer networks. So there's kind of an obvious fit from the start of just, are you actually protecting the entirety of your internet protocol space, your IP space? But then there were some non-obvious where when we were brainstorming, how can we help not just advance the attack surface management category, but the entire Palo Alto Networks portfolio, where we found, new areas for co-development. One of those was with our Prisma Cloud business. So Prisma Cloud is an industry-leading platform for cloud security that, as you were just mentioning, has a strong shift left focus, including, configuration management, so that what you're setting up in the cloud is secure from the start. One of the things that we built right after the acquisition closed was a combined view for Expanse to show unmanaged cloud assets, as well as viewing the Prisma managed assets, such that we can highlight to the customer the diff, like kind of what's managed, unmanaged, and then among things that are unmanaged, help our customers bring them under Prisma Cloud management. So when Expanse would be able to find vulnerable systems in cloud environments, commercial cloud environments, make sure our customers could then bring them under management with the Prisma Cloud product. So I would say for Expanse in particular, we had a portfolio-wide relevance that we started thinking about not even on day one, but actually like day minus, 90 days or something like that.
And what was the start of that migration? I mean, obviously it's making a plan. Where does it make sense to integrate? But you talk about the rich data that you're collecting with Expanse and the ability of Cortex to do some AI and ML on top of it. Was the first step like, hey, just dump all your data here and let's see what we can make of it? Or was there already some assumptions of models that would make sense going into that kind of collaboration between the platforms?
So Palo Alto Networks was a customer before they acquired Expanse. And so our own security operations center was using Expanse for discovery of unmanaged assets, shadow IT, and other potential vulnerabilities in Palo Alto Networks' public internet attack surface. So we did, in fact, have use cases that were proven out from how very clever folks in our SOC were using the Expanse product. And those were the first ones that we tried to flip into customer modules or customer features. So
this wasn't a T-minus 90 day effort. It was a T-minus 2 year effort.
Less than that, but yes,
okay.
it did go back even further. The prototyping of how could Expanse data help a modern SOC do even better, because to one of the things that you said, Randy, knowing all of your assets is incredibly important, because you could be spending, $500 million a year as a bank on cybersecurity. But if you don't actually know what all of your assets are, you're not uniformly applying those investments. And then when you add in the complexity of mergers and acquisitions, subsidiary business units, operating globally, we would show up to customers all the time and remind them, hey, you're doing some joint venture in, mainland China. And did you know you're using Alibaba's cloud? You're not just an Azure shop anymore. And that's when you kind of get the eyes, widening and saying like, oh, yes, that makes sense. But we didn't know, we weren't tracking that centrally as an organization.
Attack surface management and attack surface protection is something that I get annoyed at how much playtime it doesn't get when it really should. And this is a kind of a fundamental capability, and I look forward to seeing it hit more compliance frameworks as those start to be redone, because you can't apply security to assets that you don't know exist. And in today's day and age of anybody can spin up a cloud-based infrastructure and deploy some code into it so they can work from home or test things. You never know when your developer team is going to check something out and spin it up in their own environment and expose the company kind of inadvertently. So that is a much bigger topic that I will absolutely have a dedicated conversation on in the future on the podcast. But let's pivot a little bit towards XDR. So this is a buzzword. It goes back and forth on who actually coined the term, but I believe the earliest attribution was to Near and back, I think 3 years ago at Palo Alto. So looking at you guys as being the ones that define the term, what are the criteria? What are the essential criteria that fall into your expectations for XDR? Because you do have quite a bit of native sources to pull from, being that your portfolio is so expansive. So what are those kind of key elements where you say, really, you can't be considered an XDR unless you have these capabilities or this data?
So I think the most important idea associated with XDR is that the evolution of endpoint protection and prevention and detection requires joining endpoint data with other data. And so basically, if you're dependent on only one source of information at a time for security, you're going to miss sophisticated attacks. And so the genesis of XDR was, if you combine endpoint data with other relevant security data, what are new types of attacks that you can discover, or what are new forms of discovery of attacks? And that began with network data. And I still think that is the most important union in the XDR category. So endpoint data plus network security data is the most important, I think, criterion of XDR. So if you look at the prior era of endpoint protection, EDR, there is where you started to have behavioral analysis and looking at things happening locally on a machine. And that obviously was a huge leap in technology that was efficacious for a while. But then, of course, adversaries adapted and started doing a better job of obfuscation around EDR, and that required a new approach after adversaries had adapted. And joining endpoint data with network data gave us new kinds of visibility. And just to give you a conceptual example of why that is the case, let's say you have a user who browses to a website. That one action, the person went to visit a website, creates artifacts in a lot of different data sets. There's application layer work that's happening. There's a call to a DNS server. There's a destination IP address that ultimately they're communicating with. And so you're getting lots of artifacts across different products and different parts of your security stack. And adversaries are designing around obfuscating as best they can the fact that, say in this instance, the identity is calling out to something malicious. So they're going to try to obfuscate the domain being malicious. They're going to try and obfuscate the IP being malicious. They're going to try and obfuscate at the application layer that the user is doing something anomalous. And so if you're just using one source of data, you may or may not catch it. If you're looking across different data sets, your odds dramatically improve that the attacker was unable to obfuscate across everything. So by combining the different data sets into one activity, like this one user went to a website, but have it decomposed into looking at across, say, 6 different data sets, what happened, and across those data sets, run a lot of different machine learning algorithms to see, is there something unusual? And then in the aggregate, when you look at those together, is it more unusual than you would have been able to see in any one data set? You get a breakthrough in detection capability and prevention capability.
Now, I agree with that so long as we're talking about correlation, but I think there's been a lot of conflation of terms that I really want to get defined and figure out where the capabilities lie. So there's a couple of different models for those who are kind of tapping into the XDR scene now. There's hybrid and there's native. A hybrid just means that you can bring in third-party data, and native means that everything is built in-house by the same manufacturer. Palo Alto Networks and pretty much everybody else are going to fall into some level of hybrid. They're going to make things, but they're also going to ingest third-party data because you have to. Now, when you look at that data ingestion model and you look at third-party data that you're bringing in, how much of it is aggregation, meaning just stitching data together without really proving anything additional? You're more or less contextualizing, versus how much of that data is used in true correlation to say, if this plus this, now it is bad?
That is a great question, Randy. I think that is the difference between XDR and SIEM. So SIEM, Security, Incident, and Event Management, was supposed to be the answer to this problem of like the modern SOC has too many alerts, doesn't stop enough attacks, people are overwhelmed, there's not enough staff. And so you want to be able to put your data in one place and then run correlations across those data. And SIEM lets you do that, but in a highly manual, human-driven way where you have to do a lot of the data normalization yourself. And actually, SIEM created a whole labor category of security integration engineering as a result, data engineering as a result. So I think the difference is with XDR starts with the highest quality, most important security data, where the intent is not to take 200 different data sources and run queries over them. The intent is to stitch the different data into a story, like your endpoint data combined with your network data are part of the same user activity, so that you can then run models on normalized data and understand that they're part of the same user activity, as to use the example I was referencing earlier. So the difference in how an XDR product would work versus SIEM would be XDR would normalize between data sets so that you actually know the relationships between them for the highest quality data and can then run advanced analytics on top of them. Whereas for a SIEM, you might have to run queries in different data sets one at a time, or figure out correlations between them and run those correlations as an analytic in the future and update it whenever you change products, et cetera. So for XDR, I think the data integration component is fundamental. Like that's why XDR, in addition to the endpoint being the starting point for that normalization, is so important. So the idea is not just be able to run searches over lots of different data sets. It's actually to have your data in a common environment such that you know how they relate to one another, and then be able to build better analytics on top of them, including having products run on top of those data.
Yes, and I like this is the fourth time I've had this conversation, and it usually leads to like kind of, is this an evolution of SIEM or is it an evolution of endpoint? And I think what you're saying is there's a little bit missing from each one. Endpoint is missing the additional data feeds from third parties, and SIEMs are missing the ability to truly correlate across all of the different data feeds that they're bringing in and really help out with root cause analysis and advanced detections.
Yes, you said it better than me. I agree with you, Randy.
So then looking at it like that, data lake. Let's talk about Palo Alto's data lake. This thing's been out there forever. We've been putting data into it. Nobody knows where the data is going. No one knows what's happening with the data or how to get to it. So there's definitely been a lot of enhancements and functionality added to the data lake. What's the difference between your data lake and a SIEM?
So for XDR, we do the data integrations natively for the product. So we create what we would call a story. A story is basically the joined relationships between different data sets, starting with our endpoint agent from Cortex XDR and our next-gen firewalls. But we also bring in third-party data. So we're perfectly happy to work with competitors' data, make that available within XDR and joined with either the next-gen firewall or our endpoint and so on. And so we're about to release XDR 3.0, which we're calling the third generation of XDR. And what we're doing in that product is adding multiple additional data types natively. So for example, we're launching a new identity analytics module, which is going to let you natively integrate Workday data, Active Directory data. All of that is going to be natively stitched with your endpoint data and your next-gen firewall data. We're shipping new cloud functionality that's extremely exciting. We're taking flow logs, audit logs from AWS, from GCP, from Azure. We're shipping agents that can run on cloud virtual machines as well as Kubernetes containers. And similarly, natively stitching those data with other XDR data, with endpoint data, with next-gen firewall data, et cetera. So the key difference is we're not giving you the ability to just suck in another data set and then search on it or then have, someone write software on top of it to be able to create relationships. We're actually creating those relationships for you and the analytics for you as our customer. So if you're a customer of XDR 3.0 and you're connecting XDR endpoint data plus say data from AWS plus data from our next-gen firewalls, we're going to be running our analytics over all of those data and providing you with scored alerts across the data sets within the XDR unified console. So if you're an incident responder or you're working in a SOC, you're a SOC analyst, what you want ideally is to have one row, which is like the incident, this is what's happening, and then be able to expand that and see all the different relationships between the data and what alerts were triggered within those data sets. And that's the experience that we can deliver that customers would normally have to create for themselves within a SIEM or with custom software development.
Yeah, that makes sense. And also does away with that role you talked about earlier with the detection engineer, SIEM engineer, integration engineer. I mean, SIEM, just the concept of SIEM created a whole different job direction. I mean, a whole different career path. There have been plenty of people who've worked on SIEM their entire career and done different jobs every year. So it does kind of solve that problem by making it more of an out-of-the-box correlative capability between disparate data sets, almost like Hexadite. I mean, Hexadite was out 5-6 years ago. They inevitably got bought up by Microsoft. But that was really the first one that had a bunch of native correlation capabilities and native investigation capabilities based on a small set of products that you could define. So it sounds like what Palo Alto is doing is almost the next iteration of that, where you're expanding the data sets, you're expanding the functionality, and you're also providing some native view into endpoint, network, wherever the Palo Alto technology already exists.
And I would add to that, we're also pushing results into workflows. So hopefully automated workflows. So our XSOAR product is a playbook automation product where we can automate a wide range of responses and have hundreds of integrations built into that product. And then when we can't automate because it's, something that our system hasn't seen before, we can at least augment automatically the workflow for human analysts and provide as much context as possible to speed up the time to respond. So if you look at this holistically, as you just were, Randy, I think that there are 4 pieces here. There's the gathering of data, the integration of data, the analysis of data, and then the workflow. And I think what's really hard is to get all of those things to work well together. And so where SIEM excelled was in the integration component. Like if you were gathering great data, you can use a SIEM to pull it together. It would require labor, as you were saying, but you could pull it together reasonably well. But then there wasn't great native analysis on top of those data in any SIEM product, in my opinion. And then you'd have to use a third-party product or build stuff yourself. And then you would have to have the workflow, which could be in your SIEM or not in your SIEM, like depending on the organization. What we've done with Cortex XDR that we're proud of and across the Cortex portfolio is we gather the highest quality security data. We have an endpoint agent that has the deepest and longest retention on the market. And we have collection from our next gen firewalls. And we have collection from our Prisma Cloud agents. And so we're generating data, not just pulling in data. So we are gathering that data ourselves and we're integrating it ourselves. And then we build our own analysis with a large R&D team within the Cortex R&D organization. So we're making the machine learning classifiers ourselves on top of the data that we have gathered and integrated, and then we push into workflows. And again, some of those workflows are people doing things with data context, and others are automations in XOR. So I think that whole loop is extremely difficult to build, and that's what I'm proudest of Cortex having done successfully.
You definitely seem to have tackled those four pillars, and I largely agree with the pillars, with the only exception being the last pillar, of course, because you could always leverage a managed service like CriticalStart to look over your Cortex XDR instance and resolve every alert that's generated.
You would still want augmentation, so we would still want to give you all the context, even if you're having a person helping with the work. But yes.
There you go. And actually, we will be releasing a direct integration to XOR here in, I think, the coming weeks. So we did build a bidirectional integration for XOR where we can update tickets, issues back and forth and collaborate with customers through their native XOR platform. So as more adoption comes of that, we'll expand our capabilities in it as well.